Today we're going to explore temperature maps and take a closer look at the key elements you'll find on them. A temperature map shows how temperature varies from place to place at a specific time. Each color on the map represents a different temperature range. On the right side of the map, we can see the color scale, which tells us what temperature each color represents. For example, shades of red and orange indicate warm temperatures of 70 degrees Fahrenheit and higher. Shades of green represent temperatures between 30 and 60 degrees Fahrenheit, while cooler colors such as blue and purple show temperatures below the freezing point. The temperature map makes it easy to see where it's warm and where it's cold. For example, on this map, Florida is experiencing temperatures in the 70s, Michigan is in the 50s, while Minnesota and the Dakotas are below freezing, with temperatures in the 20s. The next feature on the temperature map are the isotherms. The black lines on the temperature map are called temperature contour lines, also known as isotherms. These lines connect locations that have the same temperature. The numbers at either end of an isotherm, or printed directly on the line, show the temperature represented by that isotherm. In this example, the arrow highlights the 55-degree Fahrenheit isotherm, meaning all locations along this line have the same temperature, 55 Fahrenheit. Let's find the isotherm closest to Detroit, Michigan, and see what temperature it represents. Pause the video and follow the isotherm until you reach the number printed on the line. Now, let's do it together. Moving to the left, we can see that this is the 50-degree Fahrenheit isotherm. Now, let's talk about the temperature gradient. A temperature gradient describes how quickly temperature changes over a certain distance. To understand this better, let's look at two examples. Detroit and Chicago are about 250 miles apart, and the temperature can change in very different ways across that distance. In example 1, the temperature difference between the two cities is only 5 degrees Fahrenheit, so the temperature doesn't change much over the distance of 250 miles, and the temperature gradient is weak. In example 2, the temperature jumps from 20 to 50 degrees Fahrenheit, giving a temperature change of 30 degrees over the 250-mile distance. This is an example of a strong temperature gradient. Now that we have a basic understanding of what a temperature gradient is and when it is weak or strong, let's see how we can use isotherms on a temperature map to identify zones with weak or strong temperature gradients. In Area A, the isotherms are packed really close together. That means the temperature changes quickly as you move across them, so the temperature gradient is strong. In Area D, the isotherms are spread far apart. Here, the temperature changes slowly over distance, so the temperature gradient is weak. Let's check understanding. Which area has strong temperature gradient, B or C? How can you tell where the temperature gradient is strong? A. When the isotherms are packed closely together. B. When the isotherms are spread far apart. The correct answer is A. When the isotherms are packed closely together. Closely packed isotherms, black lines, indicate strong temperature gradient.